Welcome to the Weekly Space Hangout for Wednesday, November 28th, 2018. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about Martian canyons, a cloud plume on Mars, insight, of course, a very novel geoengineering approach, and what's the best way for us to approach discussing the search for life. Joining me this week, we've got, I choose Paul Matt Sutter.
Thank you, Fraser. I choose you too. Here I am, and here's my book, which is for sale at bookstores nationwide.
You really a very professional book promoter. Good job.
Oh, man, I've gotten a lot of practice over the past week.
Kimberly Cartier.
Hey, Fraser, happy podcast day.
And Morgan Renberg. Morgan.
Hey, everyone. I'm holding a paperclip.
As opposed to a
What
book
a
to
fine
promote?
paperclip, Mr. Renberg. Doctor. Sorry.
Did you slave over that for ages and ages and submit it to a publisher, and that has been taken over your
could.
life? This paperclip?
Sent me one back.
Now, before we get into the interview, which is going to be actually very connected to what it is that I'm about to say, just want to do two things. One, remind you, of course, big thanks to the Weekly Space Hangout crew. This is like the executive producers of this show. These are the people that help make this show possible. If you want to be a part of this special community, go to wshcrew.space and you'll have all the instructions to sign up. But the other thing is that tonight we are picking at random the three winners of a copy of Mission Moon 3D, A New Perspective on the Space Race, by our special guest, David Eicher, editor-in-chief of Astronomy Magazine, and Dr. Brian May. So at some point, we will pick three numbers, and we're going to give away 3 copies of this book. Now, keep that in mind, and that's just for the folks, Nancy and Susie, so they can give me the total number that I will need to actually do the random draw from. So we'll do that at the end of the interview. But let's get into the actual interview. So joining us, we've got David Eicher. David, welcome to the Weekly Space Hangout.
Fraser, thanks so much for having me, and thanks to everyone for being here tonight. It's a pleasure to be with you. It's the first time I've ever met you.
Yeah, I know. We've been, rivals for almost 20 years now, and yet haven't actually met. So it's great to finally. I mean, I grew up. I'm sure many of the people here just absolutely grew up with Astronomy Magazine, and that's your day job, right? Is working at Astronomy Magazine.
That's my day job, yeah, but I get into trouble with some books as well.
You've got too much time on your hands. You need to write books as well.
Keeps you off the streets, Yeah.
So why don't you give us your more formal introduction? Who are you? What do you do?
Well, I'm the editor-in-chief of Astronomy Magazine. I've been at the magazine for 36 years. I got started early on in amateur astronomy many, many years ago, probably before a couple of our friends here were alive. Starting a little magazine called Deep Sky Monthly that was about observing galaxies and star clusters and nebulae. And that sort of took off. That led me to Astronomy Magazine. And I had largely a wasted youth then, also writing books.
Right. So, I mean, man, I don't even know where to start because, there's the whole thing of Astronomy Magazine, and having been at the helm of this, I'm sure everybody is familiar with Astronomy Magazine, but if you're not, it was, I mean, really, there was 2 main magazines growing up that you could read, Astronomy and Sky and Telescope, and if you were into astronomy, you grabbed both of them. Astronomy, I found a lot. I liked it better, a lot sort of more readable, better pictures, but still, 2 really useful magazines. I mean, 36 years. How have things changed over that immense period of time?
Well, they've changed dramatically. And of course, the hobby has changed. And obviously, as you guys know, we're in a period now that is absolutely on fire in terms of the science of astronomy, astrophysics, cosmology, planetary science. The hobby, though, has been relatively quiet, with people not getting into it in such huge numbers, because largely we haven't had a really bright comet since Yakataki and Hale-Bopp. Since the mid-90s. That's really something that gets people really deeply into the hobby. So younger people, are getting into it more as you're doing now online. Not so much with print magazines, but the magazine keeps rolling right along for the customers who want it. We have 100,000 circ, which is steady, which is remarkable in print magazines
Yeah.
these days.
Yeah.
And doing all sorts of things online and with digital content and with websites and so on as well.
Yeah, and I've found over the last, I mean, it feels fairly recent actually, maybe within the last 6 to 12 months or so, it's felt to me like your coverage has gotten, you put a lot more emphasis into reporting a lot of the web-based content, a lot of the news I've noticed you're beating me a lot of the time on some really interesting stories.
I don't know about that. You guys do a tremendous job.
We do. We are the greatest at Universe Today. But no, seriously, I've been finding a lot of times in the last probably 6 to 12 months, it's felt like there's been a serious emphasis. There's a lot of the kinds of stories that I like to report on, stuff that is, it's surfacing in research journals. It's coming out of conferences. And perhaps it's a lot of lesser known news, but still very interesting stuff that requires reporters with some chops to actually dig into. So has there been a more recent emphasis on web?
Absolutely, yeah, and there will continue to be on web and on digital and video. And surprisingly enough, to some degree, for people who've been around there for 36 years, our company feels that science is really a hot and growing area and is looking at acquiring things and building up the science properties. We're also now in partnership the last several years with Discover magazine, the general science magazine that's across the hall. So we share some resources back and forth with Discover, Disco as we call it as well. So that gives us a little more capability over the last year or two than we've had historically.
So let's get into the other job that you have, which is to occasionally write books with rock stars.
Well, it's a long story how this book came about, but it happened at a thing called the Starmus Festival. It's a European festival of science, and it's a long story, but Brian, as you know, was very into astronomy and actually wrote about 95% of a dissertation in 1970 on, of all things, the zodiacal dust band. Which is a little off major focus for most people who are doing PhD research. But he abandoned it, much to the fright temporarily of his family, of course, to go off and really kick up this band that was called Smile. And then this kid joined the band, Freddie Mercury, and they renamed the band Queen, and it all worked out okay in the end. But Brian has always been fascinated, and he actually went back and finished his degree then in 2008, and has always been very, very much into astronomy. And the fellow who was advising him on finishing his degree on the zodiacal dust in the solar system was the founder of the Starmus Festival. And so we got to know each other in a group, several of us in that way. And last year at the Starmus Festival, one of our mutual friends, Brian was actually not there. He was touring with Queen at the time, but the rest of us were there. And this fellow said, somebody really ought to do a stereoscopic book on Apollo and on the space race, because nobody's done it and the anniversary's coming up. And so this project was born, and I can get into why stereo as well.
Yeah, absolutely. So, if you do get your hands on a copy of the book, the thing that makes this different from really, I mean, we have definitely seen historical books about the Apollo missions, but the thing that makes this different, and you can sort of see on the back here, the entire book, almost all of the photographs inside of it are these stereoscopic pictures, which you can either use the glasses, which I was showing off at the beginning of the show, and sort of get to the right distance, and then the images pop out, or you can do this naturally and just sort of unfocus your eyes and naturally get the image to pop out. It's quite an amazing system. How did that come about?
Well, it's really sort of incredible. And Charlie Duke, who wrote one of the pieces for us, an introductory piece, said, this is really sort of like the closest we'll get ordinary folk like us to seeing really what it was like to walking on the moon. It's a bit of a long story again, but Brian, when he was a child, got very interested in stereoscopy, which was, of course, a big deal with stereo photos in Victorian times. But back in the 1950s, when he was growing up, you could get in English cereal boxes. Weetabix is a very famous English cereal. They would put stereo cards into the cereal boxes, and he became fascinated with these views, which give you really a three-dimensional view of the world around you, or even the universe. So Brian and his collaborators have been entranced with this technique and have done some other books, mostly about Victorian England in the past. But they really went through the Apollo archive, which consists, of hundreds of thousands of images, and looked for pairs. There are a few here that were faked, a few images, like the most iconic of all, which is the shot of Buzz is photographed by Neil, in which you can see the reflection of Neil in Buzz's visor and so on. There are some ways that you can fake a stereo in essence, but it's hard and it's expensive. So mostly they looked for pairs that were close in time or in rotation that you can actually match up and tweak a bit so that you can get this three-dimensional effect. Now, believe it or not, the astronauts were actually trained in stereophotography. They didn't really do much of it. Because once they were there in the transcendent moment of space flight or on the lunar surface, they were worried about other things mostly. But they took a lot of photos and moved slightly, or they took photos and a spacecraft moved slightly, or a planetary body moved slightly, and that gives us a pair that we can make a stereo 3D pair from.
Oh, that's really interesting. I had expected you to say that almost all of them were faked, that I didn't realize that many of them were available naturally, because there's a ton of really interesting, fascinating pictures of craters and things like that. I mean, I think that's my favorite part of this is it's, there's a lot of imagery of craters. Oh, I found the image you were talking about on the surface of the moon. And when you see them with that stereoscopic view, the pictures really pop out. You can really see the texture of the terrain in a way that you just don't experience it when it's just a flat image. But to know that those were two separate images taken moments apart and then stitched together in stereo, that's kind of amazing. I had no idea.
And those orbital shots were essentially all taken with Hasselblads, shooting straight out the window. It's funny because who was it? I guess it was Mike Collins, talking to him about various things about the book and the magazine. I thought, my God, I've got to ask him. And Brian actually asked me, you've got to ask him about the technique and the training in taking these things, out the window. And he said, well, I'll tell you, there wasn't much to it, really. Mike said, this was a few months ago. He said they told us what the film speed and what the exposure should be, and the thing was effectively shooting at infinity out the window when they were coming close to or orbiting the moon, as he did with Apollo 11. So as Mike Collins said, a baboon could have taken these images. I didn't expect to have that quotation from him.
I mean, it's interesting. A lot of you think that they're fairly simple images when you're taking a picture out the window, but I can't imagine it was that simple, because the amount of brightness that you're getting off of the moon is going to be changing, and it's not like a digital camera where you can take your picture, look at it and go, oh, I'm not bright enough, or I'm too bright, and then you just change some settings and take another picture. They had to take all their pictures, they were recorded in film, and then they wouldn't find out if they got the shots until they came back to Earth. Like, that's scary.
Exactly right. And you can go through on the Johnson Space Center site, the Lunar Surface Journal, you can go through the collection of images and see that there are some bad photos too, where they did get the exposure under or over. Also, won't name names here, but a couple of astronauts accidentally opened some cassettes or left them on the lunar surface,
right.
So
at some point we can go back and recover those lost pictures. They're up there still.
Yeah,
they'll be fine.
Exactly. Yeah.
Radiation isn't going to do anything to them. So right. So how much did you actually get a chance to work with Dr. May?
Well, a lot, and I was with him in Arizona recently, in fact, to do another project, and we went to do some writing about Meteor Crater, and he said, "Well, I don't want to get all rock star on you, but let's rent a helicopter." So we flew over Meteor Crater and photographed it for that. Also, I just happened to be with him to launch this book in London about a month ago, and was able to be there fortunately at the same time to do some talks with him and also go to the premiere of a Bohemian Rhapsody, which was a very nice event to go to with Brian. So,
Yeah.
he's going to be at a couple of other events coming up here. So there's a lot of Brian time that's going on here, and some other projects we're talking about doing as well.
I like that. To want to get all rock star, but let's take a helicopter over Meteor Crater. Yeah,
Hey,
I'm sure you were willing to indulge him this one time.
not something that I was, looking to do myself, but I was willing to go along for the ride, so
Yeah.
it worked out okay.
Now I mean, I'm sure you were very familiar with the material before going into the book, just having, experienced it through osmosis and so on. But what was it like to write this book and to report on the entirety of really human space travel over the course of the Apollo era, and before and a little bit after? Did you learn a bunch of new stuff in going through this process?
Absolutely. And, I'm more of a sort of being the editor of the magazine, you have to learn and deal with sort of all fields and be pretty well versed in them. But I'm more of a galaxy guy and a deep space guy. So it's not my natural turf, space exploration. We also wanted this book, which it does, to look very uniformly at the Soviet side. Of course, there was a robust Soviet lunar program, as well as the space race itself setting up, until tragic accidents basically ended that by the time of Apollo 8, and a few key deaths, of course, of Korolev and other people. So I learned a tremendous amount, and it was a real adventure to have to write this book, because it had to be done in about 6 months, start to finish, when after Brian said, well, let's do it, I'm going to publish it. So I was, as you know, Paul, you've just written a book. Fraser, you've done a tremendous amount of writing. All of you probably have. You know that when you're doing an intensive, long writing project, it's kind of like imprisonment, that's I was cranking out 3,000 words a week, every week for 6 months, so, there's a bit of sort of liberation at the end of the thing. So it was fun and satisfying. I learned a lot of tidbits that I didn't know, and particularly talking to the astronauts in person. But it's a bit of thank goodness book authors have amnesia, because if you didn't remember what this was like in the middle stage, you'd never do another project. So it was incredibly intense and quick. Honestly, this book.
Yeah, let that be a lesson to anyone who wants to write a book. You'll tell yourself you're never going to do it again, and then you'll do it again. So, well, fantastic. So people can, obviously the book is available now, both in North America and in the United Kingdom. You said they put a different cover on it, though?
It has a different cover. In fact, I have it, if you'll forgive me for a second, I have it. There's a UK, I don't know if you can see that, but this is the UK cover. I have a little reflection. It's wrapped here.
Oh, yeah.
So the UK has a different cover,
so different.
But it's exactly the same book. So,
good. Well,
marketing. What are you going to do?
Yeah, it's got to be distinctive or something.
You can find it in bookstores everywhere. It's on Amazon, and Brian has been on UK television talking about it a fair amount and all that kind of thing.
So let's pick 3 names at random, and I will share those now, and Nancy will cross-reference those names and post them in the chat, and then we will send them out. But thank you so much for giving us 3 copies of the book that we can send out. The odds are pretty good. We only got 56 people entering, so your chances, if you actually did apply, are very good. So I'm just going to, let's see, I'm going to go to my browser so you can all see. I'm all queued up here, so I'm going to get my 3 numbers. All right. Whoa. So we got, our numbers are 1, 21, and 39. So I will, I'll let Nancy figure out who those people are. David, where can people find out more about you and what you're working on?
Well, either astronomy.com, or you can look me up on social media, Twitter, Facebook, Instagram. davideicher.com is a book site that I have. But they can get me at the magazine if nowhere else.
Fantastic. All right. Well, David, thank you so much for taking the time to talk with us today. Good luck with Astronomy Magazine, and I can't wait to read more of the book.
Thank you so much, Fraser.
All right.
Good luck with all the great stuff that you're doing.
All right. Thanks a lot.
Thank you.
Okay, well, I guess now it's time to move on to the rest of the news. A bunch of good stories. Let's see, who have we got available here? Morgan's on my screen. Morgan, you get to go first.
Well, we were all very excited about InSight this week. And we're excited about Curiosity, and we've been excited about Opportunity and Spirit and Mars Phoenix. We talk a lot about stuff happening on the surface of Mars, as studied by stuff on the surface of Mars. But actually, a lot of really cool work is done by the satellites that orbit Mars, not just to do things like MAVEN is doing to measure the atmosphere, but to look down at the Earth sort of spy satellite style and figure out what's going on sort of big picture. And no instrument has been better at this than the HiRISE camera on Mars Reconnaissance Orbiter. And this is a really cool piece of work that came out a couple of weeks ago that looked at a bunch of craters on the Martian surface. And if you look all across Mars, of course, there's thousands and thousands of craters, but about 200 of them seem like they have rivers that were either leading into them or sort of escaping out of them. And what this research team did is look at a subset of those craters with rivers and sort of study them morphologically. Look at the size of the crater, the depth of the crater, the size of the channel, the depth of the channel. So you can see that channel kind of coming out from the top right of the picture. And they kind of looked at ratios of these things. And what they realized was that basically there was a proportionality between the size of the crater and the size of the channel. And on the face of it, this might seem really obvious, right? Bigger craters, bigger channels. But that actually tells us something really interesting about the ways these channels must have formed. Because we've kind of wondered for a long time, do these channels form like the Grand Canyon formed, which is very slowly from a small stream over millions, or on Mars, who knows, tens of millions of years? Or did they form sort of all at once, like a tidal wave blasting or bursting out of the crater? And because the craters, and as the craters get bigger, the channel also gets bigger, that suggests that these events happen very quickly. Because a small stream is a small stream is a small stream, no matter how big the crater is. And so if these things were forming like the Grand Canyon or like many other canyons on Earth do, then they would all sort of be the same size, irrespective of how big the crater was. But that's not what we see. We see them getting bigger, which tells us that they probably formed sort of catastrophically. Maybe the water built up in the crater, and then suddenly the wall of the crater gave way. It sort of lost its mechanical strength, and that water started rushing out. And the bigger the crater, the more water pressure there would have been, so the faster the water would have blasted, and the bigger a hole it would have created, and then the bigger the channel would be after that. And this is, kind of a little result, because, whether these things formed quickly or slowly is not really that important in the grand scheme of things. It's not even really that important, I would say, for understanding water on Mars and what was happening. But it's just really neat that we can do this. Like 20 or 30 years ago, we were saying, is there water on Mars? Now we're saying, yes, duh. Here it is in 200 different locations. And looking back billions of years, we can say qualitative things about the way that water behaved. It pooled in these craters, it blasted forth violently through a crater wall, and it formed these channels very quickly.
So I'm just trying to kind of imagine what would have been going on the surface of Mars. Like, there was a period where it was raining on Mars all the time, and you would get occasionally every few 100,000 years some significant impact that would carve out a crater, and then this thing would just fill up with water until it reached some catastrophic dam breaking point, and then all that water would exit.
So the craters many of the craters probably predated the water by a long time. But like weather patterns shift on Earth, as Mars' climate changed, weather patterns would have shifted and sent rain in different places. You have to remember that billions of years ago, Mars probably had a thick atmosphere. It probably was relatively warm, at least compared to what we see today. And so in a lot of ways, it would have behaved like Earth does. And while there are places on Earth that get more rain generally than other places, there are instances almost everywhere on Earth where you get sort of these out of nowhere monsoons that can cause these sort of catastrophic flooding events. And on Earth, we see a lot of these that coincide with glacier activity. So you have glacier kind of holding back a lake. And then as the climate either locally or globally warms, the crater or the glacier's ice thins until it becomes so weak that the water bursts forth. Whether that is what's happening here on Mars, I think, is a little difficult to say, but there is some circumstantial evidence on the surface that there was at one point glaciers on Mars. And it seems as if the same processes are happening on Mars that are happening on Earth, which kind of opens up our toolkit for how we can look at and interpret what's going on the red planet.
And so the big question, I guess, now is how long were these conditions there on Mars? Are we looking at just a few million years? Was it happening for hundreds of millions of years? Is there any idea how long they think Mars was wet for?
Yeah, the answer to that, we actually do have to go back to some of those ground-based observations from the landers and rovers. And if I recall correctly, there is some evidence that, for example, where Opportunity landed, there were periods of wetness that spanned hundreds of millions of years. Whether it was continually wet for those hundreds of millions of years, I think maybe it's a little more up in the air, but it wasn't a particularly narrow piece of Martian history that was wet. There is, spanning probably sort of between 4 billion and 3 billion years on Mars, there is evidence in different places that there was water flowing on the surface. And in some of those places that water persisted for a very long time.
So I don't know if you saw
Morgan.
this.
Sorry.
I was going to say this. This week, the European Space Agency released a report on the new rover they're testing out, the Mars Fit, I think. So they're testing out this new rover, and they were testing it in the Atacama Desert, where Paul is going to be going in a couple of weeks. And for the first time in literally centuries, it rained and made it difficult for them to operate their rover in Mars, in fake Mars in the Atacama Desert. And apparently, when these rains happen here in the Atacama Desert, it's like an apocalypse for the microbial life that is totally accustomed to not having any water falling on a regular basis. So it's fascinating to sort of think about what those conditions might have looked like over on Mars. It's so fascinating here on Earth. All right.
So Morgan, we just learned last week that Mars 2020 is going to be visiting one of these craters. Is this sort of outburst flooding something that may have happened there too? And can we explore that?
Yes, actually, Jezero crater was one of the craters that was looked at in this study, and some of the study's authors were actually the people who proposed Jezero crater as the location for Mars 2020 to go, based on this really interesting history of aquatic activity. And so whether Mars 2020 will be able to answer this particular question, I think, will depend kind of on where it lands within the crater. But it's certainly kind of in the mix of things that we might be able to address by actually going there and not just looking from orbit.
Very cool.
Speaking of Mars, Kimberly.
Yeah, so more Mars. Morgan set me up very nicely with his intro about observing Mars from orbit. And one of the things that we can do by observing Mars from orbit is get a look at large-scale atmospheric phenomenon that we may not be able to see from the ground or even from Earth. And that's exactly what the European Space Agency's Mars Express orbiter has been doing for a very long time. And just over the past month, it observed a sort of rare cloud formation near one of Mars's extinct volcanoes. This particular type of cloud is called a montane cloud or an orographic cloud. And essentially what it looks like is a very long, thin stream sort of emanating from a mountain or a volcanic peak. It looks like a volcanic plume. It is not a volcanic plume, but it is actually caused in part by the fact that there is a large prominent volcano essentially jutting up into the atmosphere. And how this works, and we see these on Earth as well, and how this works is you need first a dry lower atmosphere, say perhaps conditions after a long extended dust storm, and then you need a moist upper atmosphere above the height of a mountain. And what happens is as the lower atmosphere sort of gets pushed around the planet in a stream, it runs into this mountain or volcano. The landmass pushes the lower dry air upwards. It interacts and mixes with the colder, wetter air that's higher up in the atmosphere, which then causes condensation, which then forms a long stream of cloud, which looks like that long white streak coming off of a volcano. And we see that sometimes here on Earth. We see it more rarely on Mars, but this past year with the very long extended global dust storm that Mars experienced sort of set up the perfect conditions to have these orographic clouds, lots of dust particles to seed the clouds, really dry conditions near the ground, but still moisture higher up in the atmosphere.
So can we learn anything new about Mars, or is this just like a gee whiz, ain't clouds cool kind of thing?
We sort of can. We can learn how. So one of the unique parts about this particular cloud is that it's much longer, like physically. It's a much larger cloud physically. It's like something like 950 miles, more than 1,000 kilometers long, which is much longer than most of these clouds that we've seen on Mars and certainly here on Earth. And it's lasted for more than a month at this point. It may still be going, though. Mars Express hasn't imaged it in the past week or so. And what we can do is we can learn more about how the conditions on the ground, on the surface of Mars, impacts large atmospheric phenomenon and sort of the extreme weather events that Mars can still have today, which is a new sort of thing.
But it's definitely not a volcano eruption.
It's definitely not a volcano. It looks like a volcano.
Let's be clear about that.
It's not. I mean, it's coming off. It is caused by this volcano, but it is not actually emanating from the volcano. It's not like an ash plume or a steam plume or anything like that. It's a regular cloud, just sort of like attached to the tip of a volcano. Coincidentally, it's physics, okay?
Well, I mean, one of the big questions that Mars Insight is going to try and help answer is Mars totally dead? Or is there still some kind of volcanic activity that's going on? Is it
sort of
mostly dead? Yeah, and
this volcano is definitely really dead.
Are you like totally? Because I've heard.
Yeah, like Munchkin level with the Wicked Witch of the East. Yeah, totally.
But I've heard,
dead.
and Morgan can challenge this because it's sort of his realm of specialty, but that it's still a bit of an unknown question whether or not, like, Olympus Mons have erupted, say, within the last 5 million years, like relatively recent in historic Martian times, but more like a hotspot, like we have, like with the Hawaiian Islands, that it's just some pockets left over and they eventually make their way to the top. Is Mars totally dead, Morgan, or is this what we're going to find out?
I don't think we know for sure. I think there is some evidence that there have been eruptions on Mars in the relatively recent past, like, in the last 50 to 500 million years. I don't know if we know of anything in the last 5 million years or so. But this is true on the moon too. There's evidence that the parts of the moon have erupted like way more recently than we would have imagined. We're talking within the last 500 million years when we think the moon is billions and billions of years old. I know it's kind of weird.
It's just yesterday.
There
But
were
why would the
creatures
moon do
on
that
Earth
to
that could
us?
see it.
Yeah. There would have been creatures that could see it back early on too.
Wouldn't that have been a freaky day?
Yeah.
I mean, with eyeballs. There were creatures with eyeballs.
Right. Yeah. And nobody put this into the queue, but we absolutely have to congratulate the NASA for the Mars InSight landing. I watched it live. I'm sure you all did. Does anyone want to say a few words of congratulations?
Good job, team.
Congratulations, Insight. And Marco. Don't forget Marco did a great job. The 2 little CubeSats that could and did made it to Mars. They successfully performed as part of the communications relay. Did a great job. Took some awesome pictures. Did a little bit of radio science and then kept on going.
Yeah.
Good job.
Yeah, we had mentioned this a couple of weeks ago that these CubeSats are possibly one of the most exciting parts of this mission, that you've got CubeSats that are going to Mars that were serving as the communications relay of a larger spacecraft. We can send CubeSats to Mars and they can do legitimate science at a fraction of the price of some of these larger flagship missions. So, test bed of those technologies, the landing of Mars InSight. Now it just needs to find out if it can actually make its drill work.
Supposedly it landed in a very sandy place, so that seems encouraging.
Is that good?
For that?
Okay.
Yeah.
Seems encouraging.
Good to know.
All right, so I'm going to briefly talk about my story this week, and then we'll move on to a discussion that Paul has proposed for us to do. So now, of course, I'm sure you're all familiar with this idea of climate change. And a group of researchers from Harvard have proposed a geoengineering plan to cool down the atmosphere using particulates, spraying them into the atmosphere. So we see
Could
this.
you name the researchers, Fraser?
No, but it wasn't Avi Loeb.
Just checking.
Yeah. But he's got a new one, which we're going to definitely be reporting on. But I think you'll be
sure you are.
Yeah, I'm sure you'll be fine with it. So the plan is to essentially, back when there are volcanic eruptions, you get this fine particulate mass that's ejected high into the atmosphere, and it can cause the climate of the planet to cool down. And it's thought that some of the coldest summers that we've experienced in recent times came during these volcanic eruptions. So the question has been, and people have thought about this for a while, can we make a artificial volcanic eruption to combat the heating that's coming from the increased amount of carbon dioxide? And the answer that they have come up with is yes. And in fact, it would be relatively feasible to do this. They guess that
should we do
well,
this?
and so of course, and that's what we're that's the deeper question is, should we? With about 100 specially built aircraft, you should be able to over the course of a year pump enough of these particulates into the atmosphere to really keep pace with climate change until all the other stuff that everybody does, like cutting all their emissions, can get under control and bring those carbon dioxide levels down. The thing is, to be able to actually put these particulates into the atmosphere, you have to get above 20 kilometers altitude. And right now, that's actually higher than any existing airplanes normally fly. And you need it to be able to carry a pretty significant amount of cargo up into that altitude. So actually, there are no airplanes currently, even like really high altitude spy planes that can do this. So the people who wrote this proposal are suggesting that a new kind of aircraft needs to be built with this exact purpose in mind. But once you've built them, you can be launching these things, and with really just a fairly small number of aircraft, be constantly putting enough particulates into the atmosphere that you can really prevent the onset, the temperature rises coming from climate change. But it sounds like a terrible idea, right?
It sounds a little bit like a thing we shouldn't be doing,
Yeah.
putting
Sounds
more
like a
stuff into
great
the
idea.
atmosphere
Yeah.
that doesn't belong there.
What could go wrong?
What could go wrong?
That's what I want to know.
Yeah.
We don't know what the long-term effects of this this are.
Yeah.
The
And
hardest question, I think, is not really whether we can do it. I think we probably can. Not really whether we should do it. I think there probably is an answer to that. But like, how do we decide? Like, this is like, who gets to decide? This is the fundamental rub with climate change. Like, does the UN vote? And if 51% of countries say we should do it, do we do it?
Mm-hmm.
You know, what if Russia just decides to do it? Like, you know, are we going to go around and shoot down all of their climate change planes? Like, you know, does the Security Council get to vote? This is like, these are the sort of global governmental questions that we've effectively never been able to answer.
And
that seems like a more insurmountable challenge than the technical engineering capacity to actually put it into action.
Well, and so here's the thing. Their plan says that they only need 95 total aircraft to do this work. And the cost is about $2.25 billion per year to operate the aircraft and to, you know, to fill them with the material that they're going to be deploying to put these particulates into the air after they've designed these very special aircraft that kind of don't exist right now. So they'll have to do that. But it's theoretically possible. You need to build up, you know, really big wings, special kind of engine to take you to that altitude. But that's cheap, right? $2.25 billion, 95 aircraft that are operating over the course of a year, and you get to remove the effects of climate change.
Like, what if Bill Gates moves to Mozambique and just does this?
Yeah.
Like, you know, who should stop that? How do we deal with that?
Yeah.
That's like the question of the 21st century.
And I mean, I think that, I mean, with folks in the United States experiencing some of the fires that happened in California, this is going to be the new normal, right? You're going to see these bigger hurricanes. You're going to see these droughts. You're going to see these rainfall. You're going to see these increased fires. And at a certain point, people are going to want some kind of solution. And they're not going to want the hard solution, which is, of course, to decrease the carbon emissions. They're going to go for the simple one. So I think you're exactly right that if this is real and the technical issues can be worked out, this is fixing the climate change problem on a budget, but you're masking it, and we have no idea what the unintended consequences are over time. So
we'll just solve it then.
We'll solve that then with 200 inexpensive planes that fly up to shoot
and
the
take all of those particulate matter out of the atmosphere,
and we'll be fine.
Yeah, that shoot a different kind. And this is, I mean, we have seen these unintended.
I feel like this is the invasive species
that's exactly
argument over and
right?
over and over again.
We have seen this happen with people on Hawaii and in Australia and all these places where people are like, oh, let's send this one animal to kill this other animal. Oh, got too many of that animal, and they don't even like that animal, so let's send another one, right? And after a while, you're sending mongooses to eat your snakes, which are sent to eat your frogs, which are sent to eat the bugs. Like it's just, it's trouble. So, but at the same time, volcanoes blast particulates into the atmosphere all the time, all on their own, and we've seen the effects of this. So it would just be making fake volcanoes with our airplanes. So, yeah. Anyway, I thought I think Morgan hit the nail right on the head, which is just like, who decides? Because it's the whole planet. So I think it's it's a fascinating concept. All right, let's get into a discussion. Paul, cue us up.
Yeah, so actually I'm going to prompt this discussion, then I have to go.
Yep.
So I will say my goodbyes now. Remember, everyone needs to buy my book, at least one copy, one for each eye as you wear the stereoscopic stuff. And when you're done with Weekly Space Hangout, go over to twitch.tv/Skylius. I'm going to do a live reading from my book. And we're wearing Christmas sweaters, and it's really fun.
So immediately after this show, you're going over to Skylius, and you're going to be just
exactly
stay
so
on the internet, everybody.
I have to change sweaters. I have to do the whole thing.
Yep.
And my discussion prompt for the group that I want to go back and listen to what Morgan and Kimberly and you have to say is a couple weeks ago, I was on a podcast as being interviewed, and the host mentioned during the conversation that, we know that there are microbes underneath the surface of Mars causing methane and blah, blah, blah. And I didn't get a chance to respond to it because he changed the topic and the discussion went somewhere else. And I kind of forgot about it. Then a couple days ago, I was on the radio here in Columbus, and then the host again, totally different host, totally different city, said, everyone's interested in life outside the Earth. And yeah, we've seen little tiny microscopic wiggly things outside the Earth, but what we really care about is intelligent life, and led into the question there. And I was a little bit perplexed by it. And then yesterday at OSU, one of my colleagues, Professor Amy Connolly, came up and said, I heard you on the radio. And the host mentioned that we already have seen life outside the Earth, but we've only seen microscopic life. And she mentioned that she tends to get that a lot of people kind of just assume that we've seen life outside of the Earth because there's been so many news stories of, potential life is causing methane or little hints here and there. And I wanted to bring this up as a discussion, like, how do we deal with this and manage it? And how do we talk about the incremental discoveries that we need to do in order to discover life outside of the Earth without people coming away seeing the headline of life outside Earth, and then that's it. And then they think we've already done it. So there's my question of how do we do it best?
Thank you for that, Paul. And I will probably watch you guys on Skylius as you guys read from the book. So we'll see in 10 minutes. But until then, we will digest your talking points and come to some kind of conclusion. I'll let you know what we decide.
All right. Thanks. I appreciate it.
Morgan, Kimberly, have you guys
heard this?
Have you? I have never gotten this either.
Never.
I've gotten this from a lot of my family and friends, actually.
Really?
Who know that I study planets and exoplanets and habitable things. I've gotten that a lot, actually. My response is usually, well, no, we haven't found life on Mars.
Especially not little wiggly things.
No, we haven't found life on Europa or the moon or discovered alien life or anything like that. And I tell them how I explain it is we found all the ingredients to bake this cake of life. We found the water, we found the food sources, we found good conditions, we found carbon dioxide and methane and things that would be really nice for some of these microbes. And they're all the right ingredients, but they're not quite in the right proportions, and they haven't been cooked just right to actually make the life. And it's only a matter of time that we'll find some place that has all of the right ingredients and the right proportions that have been cooked just the right way to make the cake, which is life, which is a baking analogy, but close enough.
So, I mean, the I guess where people think that this has already happened, this must have come from the announcement back in the 90s, where they found the ALH
84001.
Yeah, where you had the little squiggly wormy microbes that they thought they had seen in this rock that had come from Mars.
I think that the confusion, again, this has never happened to me, so I'm just going to speculate wildly here. I think the confusion is actually sort of both more fundamental than that and less important. I think it tips our sort of human biases, because we talk a lot about looking for habitable environments in the solar system or in the universe and finding them. And here on Earth, where we find habitable environments, we find life. 100.0% of the time that there's a habitable environment, there is something living. And so it's wholly natural, I think, to conflate those two things. And why I think this is not such a big deal is that, it, I think, is basically true, right? We all would agree, I think, that the universe is probably pretty full of life. And it's maybe or maybe not on Mars or Europa or whatever, but there is life out there. Like, there has to be. And so I guess I don't see this as the worst of all confusions, because I think they're kind of sort of like getting the right answer for the wrong reason kind of scenario. It's not great, but it's not the worst. I don't think it's not a fundamental misunderstanding of what the universe is actually like, just our state of understanding it.
Well, I mean, people probably know I take, I challenge your, there's life out there, there has to be, there doesn't have to be. We want there to be. We think
Statistically speaking, there has to be.
We only have one sample.
But we have thousands of other examples of places where it could have shown up. And statistically speaking, we're not special. In no other respects in the universe
right.
are humans and the Earth and the solar system in any way special.
Except we're
And to be special in this one way fundamentally goes against universal cosmological principles.
Well, except we're here to be able to see it, right? If you throw a dart out of an airplane, one part of the ground beneath you gets hit by a dart, and that thinks, what were the chances of me getting hit by a dart? You'd only the dart hitty would be able to say that. So the fact is, like, we're here to be able to observe life, and we evolved on life. But if that's exactly what the only species in the entire universe would say if they experienced. But that's a whole other argument.
I mean, there could be another species just like us on the other side of the universe.
Maybe
13 billion light years away, saying the exact same thing and said, "Oh, there's no one else out there." But Morgan, I want to address something that you said, and I will start off by saying I fundamentally agree pretty much with what you said. Is that I pretty much think it's okay. They got the right answer for the wrong reasons. I worry somewhat about perhaps unintentional consequences of this, of the majority of the public thinking we've already discovered little wiggly bits on other planets, and then saying, well, why are we still spending money to search for more of this life elsewhere if we've already found it? Why aren't we looking further away? Why are we even wasting our time doing this if we've already essentially discovered it? And so I worry about that, given the precarious state of space science funding, at least in the US.
Here's what shocks me, though, is that people believe this and aren't just astonished by it. It's like, oh yeah, we found life elsewhere in the universe, as if that's not the biggest question in, Western philosophy. That's it. And to just sort of offhandedly say, oh yeah, we found it. That's just, the disconnect there is just sort of shocking to me.
Yeah, I mean, if life was found on some other world, it would be the most astonishing scientific discovery possibly in the history of humanity. If and when we do find this,
without question,
it will be one of the most important discoveries that's ever made, because it does go back to what you guys said. Now we know that we're not alone. Now that we know there's life in the universe, it makes the fact that we don't see anyone else out there in the universe even weirder. But still, it would be an important. So I think that's a great point. You're like, to know that, to go unicorns, they're real, but how come we haven't seen any out in space yet? And you're like, wait, unicorns are real? This is what you think? So I think that is actually a pretty stunning thing for people to just sort of be fine with. And maybe that goes back to that idea. People always ask, what would we do if we found out that aliens were real? But apparently nothing. Apparently everybody already thinks that aliens are real. That's pretty crazy.
I suppose they need to, stand up and wave at us.
Yeah.
For that to count. I don't know.
Yeah. Well, I
personally will be very stoked when we actually discover alive microbes somewhere, anywhere that's not Earth.
But I am waiting for someone to give me the question as Paul had described it. That's funny to me that we haven't gotten. I've never had that question, and neither's Morgan, but Kimberly has. So there you go.
I have a whole baking analogy prepped for it.
You're ready to go. You've got your answer. I don't even have one. Vernashi in the chat is saying, didn't I see some news lately about unicorns or something? Yeah, there was a unicorn rhino that was discovered
during the Ice Age in Russia or something.
So imagine
unicorns were real?
Climate change killed unicorns. Maybe that'll finally...
I mean, imagine a rhinoceros with a gigantic horn. When much bigger. So
I gotta go read about that now. Excuse me.
yeah, just search unicorn on on Google. You'll find it. All right, well, let's wrap things up. Kimberly, you're on my screen. Tell people something interesting that you're working on, and where people can find out more.
So I have my company has a very large scientific meeting coming up apparently in just 2 weeks, which is why I won't be here in 2 weeks for Space Hangouts. And so I've been frantically getting ready for that, learning all about things like giant fossilized shark teeth, outreach programs for queer and transgender youth, fun geoscience games that you can play and learn about the Earth, and why we're not exploring Uranus and Neptune.
Morgan.
Yeah.
I sort of sticking with this geology theme. I had a really great episode of SciShow Space appear this week, talking about 3 of the coolest and like most impossible mountains in the solar system. Turns out mountains are awesome, and this was a lot of fun to put together. And you can check it out over at youtube.com/SciShowSpace.
I am really enjoying the all of the SciShow videos that you're doing.
Definitely.
It's so funny to see your words come out of various people's mouths.
It's always a weird experience.
Yeah, but I can tell, like, that's Morgan. I can just tell your writing style now, just like immediately. So I'm like, oh, that's Morgan, and then I check. I'm like, yep.
It's funny. I didn't used to believe that, but then when I started reading Paul's book excerpt on Universe Today, I was like, oh man, I could hear Paul saying all of this.
Exactly. Yeah, no, absolutely. It comes through loud and clear. So congratulations. I have nothing interesting to report. So I'm just going to encourage everybody to sign up to my weekly email newsletter that I'm working on, which comes out in 2 days, although it's going to be pretty sparse this week. Not a lot of news. But go to universetoday.com/newsletter and sign up if you haven't already. All right. Well, let's wrap things up. So let's put us in the gallery view. There's all of us.
We're doing the royal wave.
Thank you to everyone watching us today. Thanks to the mods. You had some hard work today, but you stayed on top of it. I saw. Thanks to our special guest and David Eicher, who was with us, and Dr. Brian May, who wasn't able to join us. Thanks for sending a book and stressing my eyes as they focus and unfocus. If you want to join the awesome community, go to wshcrew.space and they will give you all the information. Thanks, everyone. Congratulations to the winner. And I will not be here next week. I'm not sure what's going to happen, and nobody's going to be here in 2 weeks. So just, again, prepare yourself emotionally for this to happen. All right. We'll see some of you in 2 weeks, some of you in 3 weeks, and some of you next week. So, all right. See you later, everyone.